Okay, so what we're going to do here today is we're going to work through the practice exam for section 3.5 and 3.7, which I did post to the class, the LMS class, so please look for that. All right, number one. Here it says find the domain of the rational function. All right, it's here, the first function here is f of x equals 6x over x plus 6. Okay. Now, you need to remember, when we have vertical asymptotes, they are located when you have division by 0. Okay? So what we need to do is we need to set the denominator equal to 0 and solve for x. So x plus 6 equals 0. So subtract 6 from both sides, and you get x equals negative 6. That is the vertical asymptote. Okay? Vertical asymptotes, or division by 0, is where it is not in the domain. So that means x equals 6 isn't in the domain. So in the set builder notation, which I use for these answers, the answer is x, and remember that line means such that x does not equal negative 6. Okay, that is your answer, which is A. Okay, wherever you have division by 0, you have a possible vertical asymptote or a hole. That is not in your domain. Okay? Now, number 2. All right, g of x equals 3x squared over x minus 6 times x minus 2. Okay, you're going to do the same thing. You're going to set the denominator equal to 0. X minus 6 times x minus 2 equals 0. Now remember your 0 product property. As long as one of these is 0, the whole thing is 0. So that means x minus 6 equals 0, and x minus 2 equals 0. So plus 6, x equals 6, plus 2, x equals 2. These are, again, not in the domain. Okay, so the answer is going to be x such that x does not equal 2 and x does not equal 6, which for ours is B. Again, wherever you have division by 0, those numbers are not in the domain. All right, so for our last one here, f of x equals x plus 9 over x squared plus 16. Okay? Again, you're going to set the denominator equal to 0. You would try to factor this. The problem is this can't be factored. So, because it's not a difference of 2 squares, that's a sum of 2 squares. So if you just tried to solve it normally, minus 16, x squared equals negative 16, you take the square root of both sides, you get x equals plus or minus square root of negative 16, which is plus or minus 4i. That's imaginary. Okay? And we don't worry about the imaginary numbers in the domain. That means there is no number, no real number, that I plug into x that will give me division by 0. Okay? So that means that my domain is all real numbers. Okay? Which is D here. Okay? If you get an imaginary number for the denominator, there's no vertical asymptote there, there's no hole, that is still in the domain. Okay. So that's the first 3. The second one here, number 4, excuse me, not the second one. Use the graph of the rational function to shown to complete the statement. So we have here we're looking at graphs to show what is the graph doing, okay? So here I have this. Here's my y-axis. And it looks like, according to the graph, at -2, if you notice, it never reaches -2 on the x-axis. There's a vertical asymptote there. It's not drawn, but it is there. The same for 2. Okay, because what you have here is, I'm rough sketching the graph here. You can see it on your paper much better than I can draw. Okay? And then it asks, these lines are not drawn, but it never reaches those numbers. As x approaches -2, and has a little minus sign, f of x approaches what? This little minus sign means from the left. If it was a little plus, like 3 plus, that means from the right. Okay, we'll see that on the next problem here. But right now we're just approaching, what does the graph do as x approaches -2 from the left? First of all, where is -2 on the x-axis? It's right here. Okay? Now, let me make sure. Okay. As we follow our graph, which is this line, this curved line here, so we follow the graph from the left towards x equals -2, what happens to it? It keeps going down towards what? -infinity. Okay, that might be too bright. Hold on. Let me get a better color here. Alright. That's not much better. Try to find something here. Okay, so at x equals -2, what is the graph doing? It's going down. Follow the line. What happens to it? It's going down to -infinity. Okay? That's the y value. What is the y value approach? Okay, f of x is y. Remember that. So that means f of x approaches -infinity. For instance, if I was approaching -2 from the right, this isn't the answer. So the answer for this one is, D. The answer is D, by the way. But if I was looking at x approaches -2 from the right, okay, that would be different. What does f of x approach? If you're going from the right, it's going to go up towards +infinity, okay? So it can, when you approach the same value, it depends on what direction you approach from. You could get two different answers. You could get the same answer, okay? But at an asymptote, you have to be careful. Now, let's go on number 5 here, because I'll show from the right. Okay. And the graph's a little hard to see. I'm just going to draw the part I need to draw here. So there's a part here going up. And then, so that's 1, 2. It's at 3, it looks like the asymptote is at, which makes sense, given our problem. Then it goes down like that. 4, 5, so on and so forth. So what we're looking at, as x approaches 3 from the right. Okay, again, that means from the right. What does f of x approach? Okay, so if we're looking here, as we approach 3 from the right, What is the graph doing? It's going down. It's going down to negative infinity again. Here it's going to negative infinity. If you'd approach it from the left, it'd have gone up to positive infinity. Okay? That's not what we were asked here. So that's when you're approaching an asymptote. That's how you see that. You just, what does the value approach on the y-axis? Okay? Does it get close to? It doesn't actually get close to infinity. It can't, but that's where it's going towards. Okay? So that's with vertical asymptotes. Now horizontal asymptotes are a little different. Okay? So for instance, number 6. Make sure I'm still on here. Okay. Number 6. And we'll draw, I think, so if we notice on our graph here, our lines are going, so we have -2. Looks like we have a vertical asymptote. And the y-axis is another vertical asymptote. Because those graphs, like, they veer off at those points. Okay? And so you have one going like this, and then like this, and then something like this. Okay? Now, if you notice, and it kind of ends up crossing a little bit, but it's at the y equals 0 line. You have a horizontal asymptote here. Okay? Now, when you're looking at end behavior, it's what do these lines approach. Horizontal asymptotes can cross. Okay? Note. Can cross at horizontal asymptotes. Okay? You cannot cross vertical asymptotes. Those are not in the domain here. Horizontal is different. Okay? So why is that important? Well, if we're looking at number 6, it tells us as x approaches, and it's not a specific number, it's actually negative infinity. Okay? What does f of x approach? Okay, so that's asking you, as you go towards the end, as you go to the left, towards negative infinity on the x-axis. Remember, this is positive infinity, so if you were looking at the other side, it would go the other way. All right, so here, as x approaches negative infinity, what does the graph do? Well, let me find another here. The graph goes that direction. Okay, well, what is it approaching? And if you look on your paper, it's drawn better, you'll see it is approaching that horizontal asymptote, which is at y equals 0. That's the x-axis, y equals 0. Okay, so that's where it's approaching. So the answer is there, that value. F of x approaches, it's for these. If you have a horizontal asymptote and it's asking you what you approach, it's approaching that. Whatever that horizontal asymptote's value is. Okay? Okay. Number 7's like above for number 5. Okay, so I'm going to skip that one. Alright, but if you have a question about it, feel free to ask. Discussion. Find the vertical asymptotes of any. Okay, it's number 8. Let's do back to blue here. Number 8. Find the vertical asymptotes, if any, of the graph of the rational function. Alright? Same thing we're looking for where it's giving you division by 0. H of x equals x over x plus 5. Remember, whenever you have division by 0, you have possible vertical asymptotes. Okay?